Hello friends, welcome to second chapter of our architectural visualization course. I am Oz. In this lesson, we will start learning the fundamentals of the material system of Unreal Engine 5. Let's get to it. As you know, materials are of critical importance in architectural visualization. To accurately translate your architectural design into the digital realm, it is essential to represent building materials in the computer environment in a way that reflects reality to the highest degree. I will provide you with all the information about how materials work. Firstly, let's understand what is material. Let's think about it in the real world. Every surface around us has a material, and these materials reflect light in a different way. The logic in Unreal is not much different from this. Now, as we work, we will create our materials based on this logic. To start, let's add the starter content, which I think will be useful in this section, to our content browser. Under the content browser, click on Add, Feature or Content Pack from the Add tab. Choose Starter Content and click on Add. Now, let's create a new level. We can also start creating our directory structure, which will contain most of the elements of our visualization in the next stages. Click on Add, select New Folder and rename it to UAV Course. Since this folder will be the most important folder in our future work, I am assigning a bright green color to this folder. Let's create Levels and Materials folders under this folder. In the Levels folder, right-click, select Level to create our new level. Then, double-click to open it. Since there is no light source in our scene yet, it will appear dark. You can easily create light sources by selecting the Environment Light Mixer from the Window tab and clicking on the elements you see here. For now, I won't use Volumetric Cloud, but you can use it if you want. Let's find a ground model to work on. These are easily accessible in the starter content. If you don't want to add from here, you can also add from the Add button on the right of the selection mode. Select the object here, drag and drop it into your scene, and move the position of our 3D object to the world origin from the Details panel below. Let's drag and drop a table into our scene. Our ground came in a size of 2 meter to 2 meter, so it's a bit small for us. Instead of copying and increasing the ground side by side, we can easily adjust the size of our ground by scaling it with 100 in the X and Y dimensions. Actually, I will talk about a graphical glitch that appears early. You see the ugly shadows on the object. The reason for this is that ray tracing and nanite system are not yet fully integrated. The nanite system adjusts the numbers of surfaces of 3D objects according to the space they occupy on the screen. Ray tracing, on the other hand, is a system that works by reflecting light from the surfaces of 3D objects. While nanite system reduces the number of surfaces, it can distort geometric surfaces, and ray tracing calculates based on these distorted surfaces. To prevent this, for now, we need to either disable the ray tracing shadow feature of our light source or disable the nanite feature of that object. When we do one of these, the problem will be solved. I will disable the ray tracing shadow feature of our light source to avoid killing performance. A short note: don't forget to keep the item label organized. Now, let's start by creating a new material in our Materials folder. Let's name it Empty Basic and open it. Let's drag and drop our material window next to our level for a comfortable working environment. So, what is color? It's important to understand this before we start. RGBA: red, green, blue, and alpha. In the computer environment, colors, namely RGBA, are values assigned to pixels. So each pixel is divided into a series of channels. All these channels vary between 0 and 1. You can think of this as a percentage. We determine the percentage values of colors in that pixel. 0 represents 0%, while 1 represents 100%. Additionally, the alpha value represents transparency. The closer we bring this value to 1, the lower the opacity is. For example, if you want to achieve pure red color, we set the R value to 1 and the other color values to 0. If we then increase the value of our green color to 1, we can achieve pure yellow. When creating our materials, we will focus on three main variables: base color, metallic, and roughness values. The base color defines the color of our material. The metallic value determines how metallic the material appears. And the roughness value controls how rough the surface of the material is. Values like metallic and roughness vary between 0 and 1. For example, let's talk about roughness. The closer its value is to 0, the more the material reflects light like glass, while as the value approaches 1, the material absorbs light. In addition to these, there are emissive channels and normal channels. Emissive works similarly to base color but emits light. To create a channel in the material blueprint, while holding down the number of channels you want to create, you can left-click on an empty space. For example, let's create a color with 3 channels, RGB. While holding down 3, we left-click to create our color. Then, we connect it to base color. By right-clicking roughness and metallic values, we can assign a variable which we can change later. We can start visualizing our material by dragging and dropping onto our table. Currently, due to the high roughness value, our table appears to have a smooth surface that looks like it can be easily broken, doesn't it? If we want to turn our object into a light-emitting object, we can connect our base color to our emissive color. This way, when we turn off the lights in our scene, we will have a light source that we can perceive more easily. We use such materials for televisions, computer screens, etc. Suppose we weren't satisfied with the brightness values and wanted to change them. Let's focus on that for a moment. We can start by creating a copy of our empty basic material and working on it. First, let's change the color. From here on, the roughness and metallic values won't matter much to us, so we will delete them. We can adjust the brightness of our color by multiplying the values in the RGB channels. But instead of doing this through RGB, we will use Unreal's multiply node. This node has 2 inputs. The first input takes the color, while the second input is a single-channeled value. The multiply node simply gives us the result of multiplying these values together. The higher we raise the second value, the brighter our new light will be. We can easily make our secondary value editable by right-clicking on it and selecting Convert to Parameter. We can change it to $X to indicate by how much it will be multiplied, but you can write something else. When we save and close, you will see that due to our parameter's normal value being 0, it doesn't emit any light, because it's multiplied by 0. To be able to control this in real time, we right-click on the material and select Create Material Instance. The parameters we create from this copy become easily controllable, and we will use this feature a lot. Now that we have learned the basics, we can start using textures instead of our base color. Our starter content contains many stone textures. When we transfer the stone texture to the material blueprint and connect it to the base color, you will notice that there are no details. The reason for this is that our material's normal map is not connected. The normal map is based on mimicking depth details on our 3D models without increasing the surface count. When we connect the normal map, we will see shadows on the surface, even though it's actually flat, making it look more realistic. When testing your material on your object, you might experience instances where the bricks are too large. This is because your 3D model's UVs do not intersect with your texture's UVs as you would like. Let's talk about what UVs are. UV maps refer to the process of projecting 2D images or textures onto 3D objects. U represents the horizontal direction, and V represents the vertical direction. Now, since we can't change our object's UV layouts while applying this texture, we will make adjustments to the repetition frequency of our texture. To do this, let's create a texture coordinate node with a right click. We will connect this UV value to a parameter through a multiply node. Then, we will connect the output from the multiply node to the UV inputs of our textures. With this setup, in the material instances we create, we can adjust the repetition amount of the textures by manipulating our parameter. When we increase this amount too much, we experience a decrease in realism. There are various methods to solve this problem, but for now, I believe knowing this much is sufficient. As our scenes grow, we know that the load on our computer increases. This can be a problem, especially for real-time systems like Unreal Engine. There are various techniques to stabilize the load on the system. So let's delve into one used in the material system. We can start by creating a new material. Let's name our material empty wood. We will filter the word wood in the texture folder of the starter content. From these textures, we will use the pine base color and normal map textures to create basic version of our wood material. There are also some vividly colored textures in the textures folder. Among these, we will examine T-ceramic tile. The reason for textures like this being colorized in this seemingly random way is actually because the RGB channels are used for different purposes. For example, within a single texture, one channel could contain metallic information, another roughness, and another ambient occlusion values. This way, we hit 3 targets with one arrow. If we examine these values individually, we can see that the red channel represents the gaps between the tiles, the green channel represents the tiles randomly, and the blue channel represents the tiles in an orderly manner. Now, let's try to make our joints emit lights using the red channel. First, let's create our emissive input as we saw before. If we inspect our red channel, we will see that the gaps between the joints are black. However, the color values in the area we want to change should always be closer to 1, meaning they should be white. We can achieve this by inverting the node we extract from our red channel with the 1- command. This way, we can turn the black areas into white. Now, by multiplying the pixel data of this texture with the color we select, we can change the color of our joints. Our color will be multiplied with black and white areas. White areas will be emitting light and the black areas will be normal. If you find the brightness insufficient, you can create another multiply command and make it adaptable with a parameter to change it live. Let's also adjust the normal map where the light comes out. Let's take the normal map of our ceramic from the texture folder. Now, if you want to integrate 2 normal maps together, we must first set the blue channel values of one of our normal maps to 0. Because when we add these channels, our values exceed 1. To do this, we mask the red and green channels of our ceramic normal map and integrate a value of 0 as the third channel. For this, we will use the append command. Now, let's add the obtained new data to our wood normal map with the add command and connect it to normal input. Now, let's apply another effect to our material using the same texture. Using the tile arrangement in the blue channel of our texture, let's assign green to black parts and red to the white parts. To achieve this effect, we need 3 components: the blue channel of our ceramic texture, the color we want to paint, and our wood texture. Let's start by multiplying our blue channel with our color. Then, let's mix this data we obtained with our wood texture using the lerp command. By setting the alpha value of our lerp command to 0.2, we can increase the mixing ratio towards the direction of our color. We will apply the same process to the remaining tiles by inverting our blue channel with the 1- command. After obtaining the new green painted texture, let's create another lerp command to mix the 2 textures equally and obtain our painted material. We can display this texture by connecting it to base color. Our entry to material system of Unreal Engine was like this. Try to practice along the road to understand the system. This is one of the most important sections. If you have any questions, feel free to reach out to me on the Discord server. I wish you all happy and healthy days.